Hello everyone, welcome to Dr. D. Patel Vidyapith Center for Online Learning. I am your faculty for this course, that is Performing Analytics with Python. Learners, in this session we are going to learn about unit number 4, that is Introduction to Data, Understanding and Pre-processing. So, before we could start this session, let us look at the agenda for this session. What are the topics that I am going to cover? We are going to learn about the domain knowledge. What do you mean by domain knowledge? What are the different areas of domain knowledge? What do you mean by structured and unstructured data? Then we will understand data analysis process model. What are the different steps in that? Then we look at how to clean and prepare the data with example, and then we summarize this session. So, let us start with domain knowledge. In the data science, domain knowledge refers the general background knowledge of the field or the environment to which the methods of data science are being applied. So, basically in a data science, a domain knowledge refers the environment in which we are applying the methods of data science. But when we speak about the domain knowledge of data analysis in Python, specifically here we refer the environment, we refer the skill set, we refer the expertise which are required to perform the data analytics in Python. So, when we talk about the domain knowledge of Python, so here we are talking about the expertise, the skill set which are required in order to perform data analysis using Python. So, here is a brief snapshot of what skill set, what domain knowledge that you require when you are performing data analysis using Python. First one, that is very important, that is data manipulation with pandas. How to manipulate the data using pandas, that is very important, so that we can work with the arrays, so that we can efficiently manipulate the data. The second step is data loading. How to load the data, how to import the data from different sources. We have the different sources of data, like it could be a database, it could be a file, or it could be a web resource. So, from all these different resources, how to load the data, how to import the data, that also we need to know. The third one is the data cleaning. So, when we are preparing the data, when we are analyzing the data, we need to clean the data, we need to clean the data. So, cleaning means what? Identifying the errors, identifying the inaccuracies, identifying the missing values, identifying the duplicate values and removing them. So, how to identify all these things, that comes under data cleaning. So, before we actually build the model, the data should be cleaned in every aspect, it should be accurate, there should be no missing values, there should be no anomalies, there should be no inaccuracies or missing values or duplicate values in the data. So, for that we need to clean the data. So, what are the tools, what are the functions which are required to clean the data is equally important. The next step is filtering the data. How to filter out the data? See that when we are working with data sets are very huge in terms of rows or in terms of its size, in terms of its features. But sometimes we need to filter out the data according to our needs and requirements. So, we need to know the techniques of filtering out the data from a huge data set, so that we can work with only the amount of data or the number of features that I require in order to perform the data analysis. So, here as a data analyst, I need to know the filtering techniques of how to filter out the data or how to filter out the unwanted data, what are the techniques, what are the functions, how data can be filtered, that I should know. The next one is the sorting of the data. So, here I need to sort the data either in ascending or in a descending order. I need to reorder the data sometimes according to the requirement of the applications. So, how to sort the data is also very important. So, we should know how to sort the data. Next is data transformation. Data transformation is also equally important. In a data transformation, here we are reshaping the data. Reshaping means what? Here we are adding new features into the data set, or here we are encoding, we are converting the categorical data into numerical data. So, how to reshape, how to encode the categorical data, that also very important, and that comes under the data transformation, that is reshaping of the data set. Then we need to know about the grouping and aggregation, how to perform the grouping of data and how to perform the aggregation on particular features. Then merging and joining the data. Sometimes we need to merge the data, we need to take the data from different data sets and we need to merge into a single data set. So, how to merge or how to join the data is also equally important when we are performing data analysis using Python. The next thing that I should know for data analysis, that is time series analysis. How to perform the time series analysis, such as the seasonality detection, such as the trend analysis, or we can say forecasting. So, here how to use these data and how to analyze the time series related data, the data which is collected over a time, that is that we referred as a time series data, such as seasonality detection, such as forecasting, such as trend analysis. So, all these data is collected over a time. So, how to manipulate, how to play with time series data is also equally important. And the last but not the least is data visualization. So, data visualization means representing the data graphically. So, how to represent your data by using graphs, for example maps, for example what are the graphing techniques, how to plot the data, what are the tools which I can use to represent the data graphically, so that I can find the patterns and communicate those patterns to the targeted audience. So, that is data visualization. So, these are the some of the tools or some of the skill set, some of the expertise that is required when you are performing or when you want to perform data analysis using Python, like data, how to manipulate the data, how to load the data, how to clean the data, how to filter out the data, how to sort the data, how to transform the data, how to group and aggregate the data, how to merge and join the data, how to play with time series data, and how to visualize, how to plot your data graphically. So, these are the basic things that I should know as a data analyst or as a beginner if I have to analyze the data using Python or by using the Python language. Now, let us talk about the structured and unstructured data. What do you mean by structured and unstructured data? A structured data is always well defined. For example, when you represent the data in tables, in Excel sheet, in .csv files, that data is referred as structured data, whereas unstructured data does not have a predefined structure, predefined template. For example, the image file, for example, the audio file, all these data comes under unstructured data. But here when we are analyzing the data, sometimes we need to convert the images or the audio files into a numerical data. So, how to perform or how to use, how to manipulate the unstructured data is also equally important. So, structured data refers to data that is organized into a well defined format, typically using tables or database. So, structured data is always presented in terms of either tables or databases, where each data point has a clear meaning. But unlike structured, unstructured data refers to a data that lacks a predefined structure, a predefined format, and is in the form of text, images, audio file or a video file, making it very challenging to analyze the data without additional processing. So, here I require additional processing in order to analyze the audio, video or the text data. Now, why it is important to understand structured and unstructured data? Because data is presented in different varieties. Data comes in different varieties. It comes in XML file, it comes in image file, it comes in audio, video file, JPG files. So, we have a variety of files. So, that is why we need to understand the structured and unstructured file as well. We need to find, we need to extract, we need to analyze, we need to identify the insight, we need to generate the insight even from the structured or unstructured data in order to take the decision. Structured and unstructured data are equally important, or in order to get the competitive advantage we need to know the structured and unstructured data as well. So, structured data is always commonly stored in databases in .csv files, that is comma separated value files like the Excel file. Now, let us understand the data analysis process model. What are the steps which comes in data analysis process? So, data analysis process is a systematic approach of analyzing, of inspecting, of cleaning, of transforming and modeling the data to discover the meaningful insights, meaningful knowledge, the meaningful patterns and trends. So, it typically involves several stages, and Python is a popular programming language for implementing the data analysis or for implementing these processes. So, when you talk about the data analysis process model, what is this? The data analysis process model will provide you, it is a systematic approach of preparing the data and finding out the patterns from that data and modeling the data. So, for performing all these things, that is cleaning the data, transforming the data, modeling the data, finding the insights, finding the hidden patterns, it provides a systematic approach to perform all these tasks. That is generally referred as data analysis process model, a model which will provide you the tools and techniques to perform, to inspect the data, to clean the data, to transform the data, to model the data, so that we can discover meaningful insights, the pattern of the insight patterns and trends. So, that is what a data analysis process model presents to you. Now, let us break down the data analysis process with the types, examples and Python implementation. What are the steps in data analysis process? Let us look at from the Python point of view, from the Python perspective. So, the first step is data collection. So, here what are the different types of data that can be collected? So, data can be collected from various sources. It can be from databases, it can be from APIs, it can be from web scraping, it can be from sensors, it can be from web resources or web servers as well. So, nowadays data is available everywhere in a plenty, but we need to find out the right amount of data, we need to clean, we need to prepare that data. So, first step is data collection. So, we can collect the data from different sources. There are many sources from which I can collect the data. It can be from a database, it can be from files, it can be from APIs, it can be from the web servers, it can be from by using the web scraping tools as well. So, all these are the different sources of data. So, here I need to look at the appropriate data source and I need to get the data from the appropriate sources. For example, collecting the customer transaction data from an e-commerce website. So, this is an example of how we can collect the data from a database. The second step is data cleaning. So, once you collect the data from different from the source that you have identified as the right source, the second step would be to clean the data. Cleaning involves handling the missing values, the outliers, the anomalies, the inaccuracies, the duplicate values, removing the duplicate values and collecting and correcting the data inconsistencies. So, all these activities are performed in cleaning the data. So, before the data is been analyzed, before the algorithms are been built, before a data model has been built, the data should be cleaned. So, for that we need to remove the duplicate values, we need to remove the missing rows or missing data, we need to find out the outliers and we need to remove the outliers. Again, if there are any categorical data, we have to transform the categorical data into numerical data, because to analyze the data, we should have the data in terms of numerics, then only we can analyze the data by applying the algorithms on that data set. So, all the data in a data set, more often than not, it should be in the form of numerics. For example, removing the rows with missing values or correcting the typo mistakes in data set, that can be the example of data cleaning. It can be removing the duplicate values, finding out the missing rows and removing them, or correcting the inconsistencies or the typo errors in the data set. So, these are some examples of data cleaning. Let us look at the example. Let us try to understand the activities that we can done using for data cleaning. Say for example, importing the pandas as PD so that I can create the arrays. Then we need to load the data set, that is the second thing, that data is equal to PD dot read underscore CSV, specify the name of your CSV file, in this case is data dot CSV. So, dot read underscore CSV is a function which is used to load the data set in my Python programming. So, with the help of PD, PD is what? PD is the object of pandas. So, pandas library provides the functions for loading, for manipulating, for processing the data. Like if I have to load the data in my Python program by using the pandas, then I need to use the object of pandas with its function called as read underscore CSV function, so that that data is been loaded into my Python program. So, here the data dot CSV is been externally loaded into my Python program in the variable called as data. So, now in the data variable I am having the data dot CSV file. So, here I have loaded the data set into data variable. Then the second step, that is cleaning, that how to perform cleaning, for example, removing the rows with missing values. So, here I need to find out the rows which does not have values. How to find out? Again by using the function provided by the pandas, that is data drop NA. So, here data is equal to data dot drop NA. So, drop NA function will let you remove the rows which does not have values. So, empty rows will be removed with the help of drop NA method. If you want to remove the duplicate rows, suppose that there are some duplicate rows or duplicate values, how to find out them? So, by using the drop underscore duplicates function of pandas, we can remove the duplicate rows as well. For example, data is equal to data dot drop underscore duplicates function will find out the duplicate rows from my data set, that is data dot CSV. Then how to correct the data inconsistencies? For example, data I am storing in a square bracket, data column name is equal to data column name dot str dot replace the incorrect value with the correct value. So, here if you want to correct the data, for example, if you want to correct a name, then here I can provide the name that I want to replace with another name by using the str replace function. So, here we have executed, or we have done how to load the data, how to remove the rows with missing values, how to remove the duplicate values, and how to correct the data inconsistencies. So, here we have performed the two steps, that is we have loaded the data, then we have performed the data cleaning activity. The third step is data exploration. So, data exploration in a data analysis involves summarizing the data, calculating the statistics, and creating the visualizations. So, all these tasks comes under data exploration. Here I am exploring the data, I am calculating the statistics, I am creating the visualizations. For example, creating the histograms, scatter plots, and summary statistics to understand the data distribution. So, when I am creating the histograms, when I am plotting the scatter plots, when I am summarizing my data, my statistics, so here I am performing data exploration tasks. That is the third step of data analysis process. The fourth step in a data analysis process is data pre-processing. For example, scaling the numerical features using the min-max scaling and one-hot encoding for converting the categorical values. So, here I am reshaping the data, I am transforming the data. So, pre-processing includes feature scaling, means what? Here I am scaling the data, I am standardizing the data by using the min-max scaling function, and again here I am converting the categorical data into a numerical data by using the one hot encoding functions. So, pre-processing includes feature scaling, encoding the categorical values or categorical variables, and splitting the data into training and testing sets. So, all these activities comes under data pre-processing, that is scaling the features, creating the training set and testing set, converting the categorical data into numerical data. So, all these are referred in data pre-processing. So, for example, let us understand this pre-processing by using an example. From sklearn.preprocessing, we need to import the min max scaler, so that we can scale the features. We have to import the one hot encoder in order to convert the categorical data into a numerical one. So, here I am importing the min max scaler and one hot encoder from sklearn dot model underscore selection library. After that, I want to split the data into training and testing. See that when we are building a model, we have to split our data set into training set and testing set. So, we train our model on the training data, and after that once the model has been trained, once the model has been taught, then we provide the testing data to the model, and we will check the accuracy of how the model has been trained or how the model predicts. So, here in order to split the data, we need to import the train underscore test underscore split library from the Python. So, here I am importing the min max scaler one hot encoder from sklearn.model underscore selection, and again I am importing train underscore test underscore split package as well. So, now here I am first performing the scaling of the features. So, here scalar is equal to mean max scalar. So, first I am creating the object of mean max scalar function with the name of scalar. So, now I can use this object of mean max scalar in order to transform the numerical values, in order to scale the numerical values, in order to standardize the numerical values. So, for example, data is equal to scalar dot fit underscore transform, specify the name of the column or the name of the feature that contains the numerical values, or for which you want to scale, that for which you want to scale the data, standardize the data. So, let us try to understand how to use the mean max scalar, how to use the one hot encoder, and how to split the data into training and testing. So, for that we need to import the min max scalar and one hot encoder, and we need to import the train underscore test underscore split packages as well. So, here I am importing from sklearn.preprocessing import min max scalar comma one hot encoder from sklearn.model underscore selection. So, here I have imported min max scalar and one hot encoder from sklearn.model underscore selection. Then I have to import the train underscore test underscore split as well. So, here I am importing import train underscore test underscore split. So, now I will perform this scaling. So, for that first I need to create the object of min max scalar with the help of min max scalar function. So, that is scalar is equal to min max scalar. So, here I am creating the object of min max scalar with the name scalar. Now, by using this object scalar, I am applying this scalar on the numerical features like data. I am specifying the scaled feature is equal to scalar dot fit underscore transform in the bracket data. Then I have to specify the numeric feature, that is the name of the column in which the numeric value contains or for which I want to scale the data. So, this will scale your numeric features. Then I need to convert the categorical data into a numerical data. So, for example, categorical data can be it can be a gender, it can be a marital status. So, the data which is present in categories, that is either male or female, either married or unmarried. So, here I need to convert this categorical data into a numerical one. So, for that I need to use the function that is one hot encoder. So, here encoder is equal to one hot encoder function. So, this will create the object of one hot encoder. So, now by using the encoder, that is the object of one hot encoder, I can apply this object, I can use this object on the categorical data. So, that the categorical data can be transformed, can be converted into numerical data. For example, encoded underscore features is equal to encoder dot fit underscore transform, specify the column name of the data set in which the categorical data exists or for which you want to convert the categorical data into a numerical one. So, this will, so in this example here we have applied, we have scaled down the numerical data by using the min max scalar, and after that we have converted the categorical data into a numerical one. So, now let us understand the data modeling, that is the step of data analysis, that is the fifth step of data analysis. For example, training a linear regression model in order to predict the sales based on advertising expenditure. So, here I am building a model. For example, I am building a linear regression model in order to predict the sales of a particular product based on the advertising expenditure that I have incurred. So, here I am building an model. So, here modeling involves selecting and training the machine learning model to make the predictions or to classify the data. How to implement this in Python? By using the scikit-learn or other machine learning algorithms or machine learning libraries for model building. So, for model building I can use the scikit-learn or other, for example, machine learning libraries in order to build the model. Let us understand this, how to build a model and how to predict. So, for that first I need to split the data into training and testing. So, split the data into training and testing is very important. Like I said that when you are building a model, for that we need to have two sets of data, that is a data set has to be divided into training and testing. So, here we train the data by using the training data. So, once the model has been trained on the training data, now I can use the testing data to identify or to know that how well the model has how well the model has learned from the training data. So, here I can compare the result of my model when I provide the training data and testing data. I can find out the accuracy of how well my model has been trained by using the testing data. So, here I need to split the data into training and as well as testing data. For example, x underscore train comma x underscore test under x underscore test comma y train comma y test. So, here I am creating x underscore train and x underscore test. In the same way I am creating y underscore train and y underscore test is equal to train underscore test underscore split is a function. I will provide the features, that is the column names. I will provide the target source, targeted where I want to store the data, that is the target. I will specify the target. Then I can specify the test size, what will be the size for testing data and training data. Then I will provide the random underscore state is equal to 45. So, this will divide the data set into training and testing sets. So, now here I am building a model. How to build a model? How to build a linear regression model here? So, to train a linear regression model, this is the code that I can write, that is model is equal to linear regression function. So, first I am creating the object of linear regression with the name that is model. So, now I use this model on my training data. So, here it means that model dot fit, in the bracket I am providing two arguments, that is x underscore train comma y underscore train. So, it means that here I am training my model, that is linear regression model, by providing the x train and y train. So, here I am training my model, my linear regression model with the training data. So, once the model has been trained, now the model can predict, the model can make predictions. So, how to provide or how to make your model to predict. So, for that I can use the model dot predict function on the x text on the x underscore test data. So, here once my model has been trained, now I want my model to predict on the testing data, so that I can find out the accuracy of how well my model has been trained or how well my model has learned from training data. So, in order to make your model to predict, we have to use the function called as predict on the model. For example, predictions is equal to model dot predict. Here I need to specify, I need to provide the testing data, which is x underscore test. So, after that you can print the result of the prediction. The next step is model evaluation. Model evaluation is very important to assess the performance of your model. That can be assessed with the metrics such as the accuracy, such as the RMSE, such as the F1 score, etc. So, by using the metrics, that is accuracy, RMSE, F1 score, I can assess the performance of my model. Means what? I can evaluate the performance of my model by using some of these metrics. For example, calculating the mean absolute error, that is MAE, mean absolute error, I can check the accuracy of my model. So, calculating the mean absolute error value or function to evaluate a regression model. So, in order to evaluate a regression model, we can use the MAE, that is mean absolute error function, to find out the error or to find out the accuracy of how well my model has predicted. Implementation, how we can implement? We can implement this by using the scikit learns evaluation function. So, here I can do that by using the MAE, that is mean absolute error function, in order to evaluate the regression model's performance. So, this is model evaluation, where I am assessing the performance of my model, and I will use the metrics such as accuracy, the RMSE, F1 score, etc. So, these are the metrics by which I can use to assess the performance of my model. So, for example, from sklearn dot metrics, we need to import mean underscore absolute underscore error package. To evaluate the model, we have to use the MAE, that is mean absolute error function. So, for that MAE is equal to mean underscore absolute underscore error. Here I need to specify, I need to provide the testing data, that is y underscore test. Now, I have to provide the predictions. So, here what I have done here, the predictions that I have done in the last step, that are available in the prediction variable, and I am providing y underscore test. So, here I can check what exactly is the difference between the accuracy level of my model. So, here I am providing y underscore test and predictions, 2 arguments to this mean underscore absolute underscore error, so that I can assess the accuracy level, the prediction, the accuracy level in terms of its predictions by using this mean underscore absolute underscore error function. After that, I can print the value which is present in MAE variable, which contains the MAE value, but with the help of print function, that is print mean absolute error, we can specify the name of the variable, that is nothing but MAE. The next step is data visualization and reporting. So, here for example, creating a dashboard or creating a report which will summarize the analysis and insights, that are the activities that comes under data visualization and reporting. So, here I am visualizing the results and generating the reports to communicate the findings to the targeted audience effectively. How to implement this using Python? Using visualization libraries which are available in Python like matplotlib, like seaborn. I can use these tools in order to graphically represent, in order to plot my data sets or plot my findings, so that I can communicate effectively to the targeted audience. And tools like Jupyter notebooks I can use, or I can use the reporting libraries, for example the PDF generation libraries as well. So, all these are the tools which are used for data visualization and reporting. The next step is the model optimization and tuning. So, fine tuning the model means here we are fine tuning the hyperparameters, we are optimizing the features, feature selections and employing the techniques like cross validation. So, the cross validation function, cross validation technique is used in order to optimize your model. For example, using the grid search to find the best hyperparameters for a machine learning model or for a machine learning algorithms. So, basically here I am using the techniques like cross validation in order to optimize the hyperparameters. How I can implement this? By using the scikit-learn's grid search CV or other optimization techniques. So, for example, from sklearn.model_selection, I need to import the grid search CV, and to define the hyperparameters to search, I write this statement like param_grid is equal to, I will create a dictionary here, then I will create a grid search object like grid_search is equal to grid search CV, estimator is equal to svm_model, comma param_grid is equal to param_grid, comma scoring is equal to accuracy and CV is equal to 5. Then grid_search dot fit in the bracket xtrain and ytrain. Now, to get the best parameters, we need to write best_params is equal to grid_search dot best_params. So, this will get you the best hyperparameters or best parameters list. Now, I am printing it with the help of a print statement, that is print best parameters, specify the variable in which I have stored the best parameters, that is nothing but best_params. So, this will print the best parameters. The ninth one is the interpretation and insights. Again, this is very important. For example, analyzing the features important, the coefficients in a regression model to understand their impact. So, interpret the model means here I am interpreting the model's result, I am extracting the meaningful insights and make the data driven recommendations. So, these are the tasks or activities that can be done in interpreting or interpretation and insights, that I am interpreting the model's results and extracting the meaningful insights and I can make the data driven recommendations once I complete this interpretation and insights. The last step, that is the 10th step, is the deployment and automation. So, here I am deploying the machine learning model, that is in this process I have created the regression model. So, here I am deploying that regression model in the environment as say REST API using the Flask. So, these are the some of the techniques, tools which I can use for the deployment, that is I can use either Flask or I can use Django or the automation tools like Apache Airflow. So, to deploy the model for real time predictions or automate the data pipelines or integrate the analysis into existing system, I need to deploy the model that I have built. And to deploy, I can use the tools like Flask, the Django, or I can use the automation tools, that is Apache Airflow as well. The 11th step is monitoring and maintenance, that is the last step of data process model. So, for example, implementing the regular model, retaining the based on new data. So, continuously monitoring the model performance and retain the model as needed and update the data analysis process as and when required. How to implement in the Python? Setting up the monitoring scripts and schedule the jobs. So, in this way I can continuously monitor the model's performance and I can retain the model as needed and I can update the data analysis process as it required. For example, implementing the regular model, retaining it based on the new data. So, continuously monitoring the model and at the same time we need to update the data analysis as and when required. How it can be done in Python? By setting up the monitoring scripts and scheduling the jobs for continuously monitoring and maintenance. So, with this we come to the end of this session. I hope you enjoyed this session as much as I did. Thank you for watching.